Hi, this is Mark Roth, and this is Mathematics for Social Justice. So today we have another bowling pin puzzle. I'll just give you an example. Suppose we choose some numbers from this set for the bottom row. Suppose we choose 10, 4, and 6. Now, when you multiply 10 times 4, you get 40. So we'd have to find 40 on this clock. And we don't want to count 1, 2, 3, 4, all the way to 40. So what we do instead is subtract the number on this list, which is the multiples of 14. But we want one that's smaller than 40, which is 28. 40 take away 28 is 12. So again, we want to multiply 4 times 6 on this clock, 24. We take away 14 and get 10. And 12 times 10 is 120. Take away 112 and get 8. Let's see if we found any repeats. Well, we did. We got 10 twice. So as soon as you get a repeat, you know you failed in solving the puzzle. So we want to get all these numbers in the triangle, but with no repeats. So to work on this, we can get some help by an article by K. Robin McLean, which you can find online. It's called Groups in Modular Arithmetic. So he showed how to find the unit. Well, actually, we'll call it the identity. We want to find which number in here, when you multiply it by a number, you get that number back. If 8 was the identity, 8 times 10 would be 10. And 8 times 12 would be 12. So let's see if 8 possibly could be the identity. How would you do that? Well, let's let the identity be E. And when you multiply E times E, you get E, because that's what the identity does. The identity times anything gives you that number back. So this is a special property of the identity called idempotent. It's the only number that when you times it by itself, you get that same number back. That word is idempotent. We can take this E times E equals E and change that to E squared equals E, and change that to E squared minus E equals 0, and factor that as E times E minus 1 equals 0. And this time we could see that 8 would work, because this would be 8 times 7 equals 0, because 56 is a multiple of 14. 8 times 7 would give you this. It shows you that 8 might be the identity. Well, let's check that. 8 times 2 is 16. Take away 14 is 2. 8 times 4 is 32. Take away 28 is 4. So we're finding out 8 times 4 is 4. 8 times 2 is 2. Let's see if we can find the inverse of each number. So, for example, if we take 2 and we want to get 8, that would obviously be 4. So 2 times 4 is 8. And let's try 6. Now we want 6 times something to be 8, if 8 is going to be the identity. Actually, I think 6 times itself will be 8. I think it's its own identity, because 6 times 6 is 36. Take away 28 is 8. So 6 is its own inverse. So what about 10? Well, the only thing left, I think, would be 12, because 8 is, if 8 is the identity, it's going to be its own inverse. So 8 times 8 is 64. Take away 56 is 8. And 10 times 12 is 120. Take away 112 is 8. What we learned in previous videos is the identity has to be on top. Because if 8's the identity and you times it by, say, 6, you would get another 6. So 8 would have to be at the top. And this here, we would have to have a partner pair. So it'd either have to be 2 times 4 or 10 times 12. Let's just try 2 times 4. And then we have to put 10 times 12. But we can't put 10 times 12 here and here, because that's not 8. And we can't put 10 and 12 here and here, because that's not 8. So 10 and 12 have to be on the outside. And that means the other number 6 would have to go there. So 6 times something would be 2. What should we try? Let's just try one of them. Let's try 10. That doesn't work because if we tried 10, that would be 60, and 60 minus 56 is not 2. So let's try 12. 72 take away 70 is 2, and that means this should work. 60 take away 56 is 4. And we solved the puzzle. So we're not quite finished because we'd like to see if there's any other solutions. I believe 8 still has to be here and 6 would have to be here, but we could try putting the 12 and the 10 here. And then we're going to put the 2 and the 4 down here. So 2 would have to go here because 2 times 6 is 12. And 4 would probably go here. 24, take away 14 is 10. So I believe we found all the solutions, not counting mirror images, as being different.